We're now going to answer some slightly different questions. It says, sometimes solving an exponential equation involves solving a polynomial equation first. In the following example, the solution of a quadratic equation is necessary. So let's look at this one here. So it's asking us to solve this. And as you can see, it's quite different to what we've previously seen. The first thing that we're going to do is try to make the bases the same where possible. So this 4 is the same thing as 2 squared, right? And I've still got an x there, the x. Plus now this has already got a base of 2, which is great. And then I'm just going to leave this as it is. Okay, the next thing that I want you to notice here is that I could swap this 2 and this x around, couldn't I? Because this is just 2 times x. So I could write it as that and then the 2 there. Hopefully you can see that there's no difference there because this just means 2 times x. X times 2 is the same thing. And then we keep on writing it out as I see it. Okay, what we're going to do now is I can now say, well, let a be equal to 2x. Now, why have I said that? Let a be equal to 2x. Well, we're about to see why. Every time I see a 2x, I'm going to replace it with an a. And this didn't have to be a, it could have been any pronumeral. So that means I'm going to be ending up with a squared plus a minus 20 is equal to 0. Okay, I have a quadratic. This is a quadratic. So I have made a quadratic out of what we were just doing. And now I just need to factorize this quadratic. So what are two numbers that multiply to get to negative 20 and add to get to 1? Well, that's going to be a plus 5, a minus 4 is equal to 0 because 5 times negative 4 is negative 20. 5 plus negative 4 is 1. Okay, then we can use our null factor law, which simply says we take this and we set it equal to 0. So that means a is going to be equal to negative 5 or a is going to be equal to 4. And then once we're here, we can't stop. And the reason why is because, we've introduced a. A wasn't something in the question. So we need to now get our answer back to being in terms of x, because when it's asking us to solve, it's asking us to figure out what x is. Well, I just put this information back. So if a is equal to 2x, I can therefore say, well, negative 5 is equal to 2x, or a is equal to 4, so 4 is equal to 2x. All right, this is where you have to be a little bit discerning now. Is this possible? Negative 5 is equal to 2x. What would x have to be to get a negative number out? And hopefully you can see that that doesn't work at all. There's no solution to this part. The reason why there's no solution is, even if I put in a negative number there, even if I made 2, negative 3, that's just going to become 1 on 2 to the positive 3. There's no way to get a negative out there. It just doesn't work. And so when you're in this situation there, you say no solution. Over here, hopefully you can see, well, 4 is the same thing as 2 squared equals 2 to the x. Therefore, the only solution is x is equal to 2. That's my only solution. So let me highlight that. X is equal to 2. Okay, hopefully that made sense. It is a bit of a tricky one when you're dealing with quadratics, but you might like to now pause the video and see if you can do the next question for yourself.